Hey guys, welcome back to another episode of the Weekly Coder. I'm Chris, and today we are going to continue on where we left off from our previous tutorial. You'll never guess what happened to me. Like, literally, I just recorded this entire tutorial, and sadly, I had to start over from scratch. After about 30 minutes of recording, I thought I was finished, and then I went to review it, and there was no audio. Because why? Because I forgot to turn on the mic. And then I didn't even check to see, like, I usually, man, I'm usually so good about this. I'll go in, I'll do like a test, and I'll make sure, is everything good? And yeah, all right, we got a test video, now let's make the real one. But for some reason this time, like, okay, not happening. Which is good in a way, because as I was working through the tutorial, I had well, not a lot, but a few stumbling blocks. One main one, we're going to fix this right now so that I don't forget again. There was an issue with the tiles when they were like loading up. They were off-centered. And but you know what? I'll leave that in there because I'll show you what happens if you don't do this. So we'll just forget I even said that. I'm going to pretend like it's the first time I see it. You'll get to see my fake excited face. All right, so from there, let's talk about what we did previously, right? What do we do? We created this. We did the whole setup. That was the first tutorial. Second tutorial was we went in and we created this game class, and then we played with CFDebug, a little script I wrote. In the game class, we created a get random location for new tile method, which in turn creates a random location for a new tile. We didn't have much use for it back then. It's just kind of like a theoretical proof of concept kind of thing. We ask for a new location, we get a new location. Perfect, right? And we played with a little with this CFDebug script, right? We created this awesome little window here that we could see things with. So we could press the button and it would tell us what button was pressed. That's cool. Press the down button and it generates new locations for tiles, which is awesome. So everything's working like we wanted to up to this point. What I want to cover first is I had a chance to play around with the CFDebug script some more. I actually I started writing it when I created the last tutorial. And after that, I was like, well, it's cool, but, we could still improve upon it a little bit. The way it looks now is it's basically this. Here are all the values, you set them, and you're good to go. You're done. They're not in any cool right order. They are not like grouped or anything. This just looks kind of, noobish, I guess, in a way. And that's because I really threw this script together super fast, and I just wanted to get it out there. Now, what I've done is I created a new CFDebug script. So we're going to delete the old CFDebug script, and we're going to copy over the new CFDebug script. And that is here, and I'll put that as a download. Right, so we've got the new CFDebug script, and now in our debug game object, we need to make sure that, oh, look, it's already there. How about that? That's awesome. Unity is so great sometimes. And we just have to make sure that our grid, our grid has our debug script here as well. So all that looks great. So let's go back to this for a second and look at this. All right. So I beautified it, or I guess you could call it beautify. I polished it. It looks a lot better now. So there are a few things, and I'm going to press play to show you some of the features here. One, you'll notice that the game time is now included in as part of the script so that you don't have to add that in yourself. So you can turn the debug on or off. You can, of course, show or hide the box. You can show or hide the frames per second, which I also thought was kind of a nice thing to add in so you can see your frames per second in real time. You can show or hide the current game time. You can change all these values. These are the same values that we've had before with a few new ones. We have our informational, warning, and error colors for fonts, and I'll show you how these work in a second. But for now, we can still like press left, right, up, down, still does that same thing. Another cool thing I added was the ability to turn off individual debug messages. So we can go in and we have our current time, our player pressed key, and our new random tile location. So let's say we don't want to show this current time anymore. We just hide it. We don't want to show this pressed key. We don't want to show this. All right. That's kind of boring now, but basically, yes, you can turn off individual messages, which is kind of cool. So that is that. So we can now just basically stop and we can go into our game script, and I'm going to show you how to add an error, like an error warning if you want to change, like if you want a different kind of color, right? So, and that would be like in an instance where, let's say that you have a part of your script where you're like, ah, man, all right, I don't ever want this to happen ever, you know, but I'm going to have this if statement that says, if this, then we're going to do this, and then we're going to say else, this should never happen. So we're going to have that one piece that says, well, we don't ever want this to happen. And you know, it would be easy to just say debug.log, this should never happen, or just put some comment there and say this should never happen. But wouldn't it be cool if, like, in the game, it showed us right away with a big red message that says, hey, this shouldn't happen? We can do this. We can say, like, for instance, if we don't ever want to, or hope that no one ever presses the up key, we can just add a little thing here to the back and give it a message kind. So we say cf debug object dot debug message kind dot error. Save that. Go back to Unity. So now, if the player presses left or right, it'll still log those. Down also logs that and generates a new tile. If the player presses up, that is now shown in red. Okay, how cool is that, right? So, and we can, of course, go in and change those colors. So if we don't really like the red, we can go with blue, or purple, or green, whatever color you want. Pick one. All right, so that's pretty much the CF debug object, version 1.1, I call it. We will go with that. And so after that, there's not really, I mean, you can change it also to a warning or whatever. And I'm still working on improving this, so you might see a version 1.2 in the next tutorial. Or if there's any cool features that you can think of that I might be able to put into this to make it even better, that'd be great. I'd love to hear them. Suggestions are always welcome. Okay, so that covers that. Now, we are going to create some more code. Well, we're not going to create code. We're going to create methods with code. That's what we're going to do. So, the first thing we're going to do is we need to be able to, in our game, and this would be the logical step that you would probably follow if you were to create this from scratch without any tutorials, is, so you would probably want to generate a tile for your game. And in order to do that, we want to create a method for that, because that's a pretty involved, complex kind of thing that you're not just going to want to write in another method. Like, you wouldn't write in the start method, you wouldn't write the code that generates the tile. You would call a method that does that for you, okay? Because we're going to do this repeatedly. We're not just going to generate new tiles when the game starts. We're also going to generate new tiles when a move is made. Okay? When you move to the left, when you move up, down, right, yes, that's all the directions. Then you're going to want to call this method that is going to generate new tiles. And this method is going to be called generate new tile. How about that? Now, the question is, when we generate new tiles, how many do we need? Well, when you're playing the game, you only need to generate a tile every time you move. When you start the game, you need to generate 2 tiles. What if you want to make your game more complicated? What if you want to generate more than 2 tiles? What if you want to generate 3 tiles or 4 tiles? Or 2 tiles at every turn? Well, instead of just creating the method to generate 1 tile at a time, we can create that method so that we can specify how many tiles that we want to create when we call the method. In order to do that, we need to add in a parameter. So this is going to be an integer value because it's just going to be a whole number like 1, 2, 3, right? And we're just going to call this how many. Right? So now we've got our new method name, generate new tile, and we have a parameter that we can pass in that is going to be of type integer, and we're going to call it how many. Notice that I started the method off with void. That means that our method is not going to return anything. All it's going to do is it's going to do some things for us, and then it's just going to go away. So in order to process this, integer, this how many variable, we need a way to kind of, go in and then just manipulate it. We're not going to manipulate it, but we are getting information. Okay, we're giving information to this method. We're saying how many tiles we want to generate. And we're not going to say if how many equals 1, then generate 2 tiles. If how many equals 3, then generate 3 tiles. We are going to just write a for loop. So we're going to say for int I equals 0, I is less than how many, and then plus plus I. All right? So now what I'm doing here is I'm iterating over the variable how many, all right? And then what we're doing is we're in this for loop is where we're going to generate our new tiles. So every time this for loop runs, we're going to generate a tile. So that's how we do that. We say how many tiles we want to generate, and then we say how many here, and as long as our value here is less than how many we have, we're going to continue generating tiles. This first one, right, is going to be I equals 1, because what happens is this processes, and then it increments I, so I equals 1, and then it's going to run. The next time this runs, I equals 1, which is still less than how many, right, if we say 2, and then it's going to increment I again, and I will equal 2. The reason that we do this is because that way we can still say I is less than how many. We can start with 0, and since we're not working with arrays and we're passing in an actual number 1, it would be easier to just increment I before the processing, right? So what we're going to do is we're going to use our method that we made last time. We were going to use this get random location for new tile because when we generate a new tile, we need a random location for it. We actually need to put it somewhere. So we're going to say, we're going to call vector2 location for new tile equals get random location for new tile. Just like that. Okay? So that's the beautiful thing about methods. When you're creating a method, you can create it with whatever you want. You can create it so that you can pass in parameters, you can pass it, whatever. And you can set it to return values, you can set it to just be voided, you can, whatever you want. And then when you call it, it just becomes this one line of code. That's it. That just, to me, is the best thing ever, right? A function is just there. It just does what it's supposed to do, and it's all right, I'm rambling. So let's keep going. What we're doing is we're creating a vector2 because, of course, we are returning a vector2 from our get random location for new tile method. So we are now creating a variable of type vector2 that is going to store our vector, which is the x and y location of the tile, or the location for the tile. Okay? So the next thing that we're going to do is we are going to say, we're going to create a string variable, that's lowercase, and we're going to call it tile, and we're going to set that equal to tile underscore 2. As you'll remember, our prefabs are named tile underscore 2, 4, 8, 16, 32, 64, and so on, so that we can easily reference them in the game. And I missed a T here. Alright, so by now you guys know this yellow line basically just means that, yes, we've created a variable, but we're not using it anywhere. So that's great. We're going to use it very, very soon. The next thing we're going to do is we're going to create another game object, and we're going to call this new tile. And we are going to set it equal to a casting game object to instantiate, right? So we're going to instantiate a game object. We're going to use resources.load. And we are going to load in tile, and type of will be game object. And then we're going to pass in the location for new tile, and we're going to pass in quaternion.identity for the rotation. And then finally we're going to set the parent of the new tile to this transform. Alright, so what does this do? This basically creates a method that has a for loop that iterates over the number of times that we want to generate new tiles. In the for loop, okay, we're getting a new location for our tile, which will be an x and y coordinate. We're then storing the name of tile 2. We are then creating a new tile, game object. We are casting game object to instantiate. We're then using the resources.load method, and then we're passing in tile, which is the name of the resource right here. And then we're saying the type of resource that we want to instantiate is a game object. Okay? And then at the location that we want to instantiate this game object is going to be our location for new tile, which is our vector right here. And then the rotation is just quaternion.identity. The next line, all that does is it makes it so that the new tile that we just created, when it gets added to the hierarchy in our game, is the child of our grid game object. The grid game object, remember, is the game object that the game class that we're right in right now is a component of, right? So that's important because we want to keep all of our tiles that we create in one parent, and that makes them easy to organize and basically, manipulate, that's the word I was looking for, manipulate later on. So with this, what we can do is we can now go to the start method and we can say generate new tile, and we're going to pass in a 2 because at the start of the game we want to start with 2 new tiles. So let's go into Unity and see what that looks like. Hey, look at that, we got 2 2s, but something is really, really wrong with our 2s. Why do we have 2s here? Why are they not centered? Oh my god, what's going on? This is my crazy, fake, excited face. This is the problem I ran into last time, and I'm like, why? Why? What did I do? Why is this not working right? So to understand, what happens is we put this grid at 0, 0, at the 0, 0 location, to 2, 2 location. Anyways, it's aligned at a whole number. These tiles, every graphic basically starts with a point in the middle, in the center, okay? These graphics are 1 unit. And at 100 pixels per unit, we're looking at a pivot point at the 50 pixel mark in the center. Okay, so 50, 50, 50, right, 50, up. So 0.5, if you want to think of that as in if you have the entire unit represent 100, then if you have half of a unit being 50, you would look at 0.5 as being half of that unit, right? So we are working right now with 0.5 locations. Decimal, floating point. No, we don't want that. So the way to fix this is to change our pivot point to not be in the center, because if we changed our pivot point to be like down bottom left, it would then move that piece to be right here, okay? So what we're going to do is we're going to go to our graphics, we're going to select tile 2 all the way to tile 2048, and up here, right here, you see the word pivot and how it's set to center? We're going to go down to bottom left. All right, and that's it. So now we press play again. Now when our 2 tiles are generated, Oh, we have to apply the settings, of course. Now when our two tiles are generated, they are perfectly centered in the squares. All right, so now we can stop this and we can start it again. And we can stop this and start it again. And our tiles are basically being generated where they're supposed to be. Now the other cool part is we have our debug statement. It doesn't give us both locations, but it gives us the last location of the tile, the last generated tile. So we've got 3, 3, so that's x and y. So 3 is x and this 3 is y. The grid works this way. We've got 0 right here, and then 1, 2, 3. That's the x-axis. Then we've got 0 and 1, 2, 3. Right? So this is saying location 3, 3. So 0, 1, 2, 3 in the x, and 0, 1, 2, 3 in the y. And we see that our tile is right here. Awesome, right? Now, as you may have noticed, we have one other issue. And that is that we're always getting 2 2s. And the reason for that is simple, is we did not put any logic into our game that says, hey, you know what, sometimes let's have a 4, not always a 2. At the same time, we also want to make sure that we don't have it like in a 50-50 split, right? So, or that we don't want to say, you know, well, did you have a 2 this time? Let's make it a 4 next time. We don't want to always have that 50-50 split. We want to have 2s most of the time and 4s some of the time. So a quick and easy way to do that is to create a variable. Let's call it chance of 2. And let's get a random range going. Okay? And we're going to specify 0f and 1f as the minimum and maximum numbers. So what we're doing is by using the float type, we are telling it to generate anything between 0 and 1. So that could be 0.1, 2, or yeah, 0.12, 5, 6, 8, 9, 10, or 1, 0, whatever. It could be 10. It could be any basically floating point variable anywhere between 0 and 1. So the next thing we're going to do, if chance of 2 is greater than 0.9, then we're going to change our resource name from tile 2 to tile 4. See, that right there will give us about a 90% chance of scoring a 2 tile versus scoring a 4. So that means that 10% of the time, about 10% of the time that we're calling this method, we should be getting a 4. All right? So let's save that and go back into Unity, and let's see if we can make a 4 happen. So we'll play. And 2 2s. 2 2s. And a 2 and a 4. Cool, right? So it's working exactly how we, kind of imagined it to work. So that's pretty cool, right? So we are making progress here, right? So from now, what we need to do is we need to go back into our game class, and we need to create another method, right? Because what good is creating these, right? If we generate these tiles, we see them visually, but once we start like moving them around, like left, up, right, down, those directions, the 4 directions, left, up, right, down, left, right, up, down. Those directions, what'll happen is they're going to basically just start moving across the board. And we need a way to keep track of those. And that's why we created that grid matrix at the very beginning, like way up here. We defined our grid width, right, and our grid height to be 4 by 4. And we're also basically creating this grid right here, the grid matrix, and we're going to set it so that we can store transforms in it. So now we are actually at a place where we can create the method that will basically keep our grid updated. So a method that we can call to update our grid whenever we make changes that we want to let our grid know about. So let's write that method real quick. So we do void update grid, and we're not going to pass anything, and it's not going to return anything. And what we're going to do with this is we're basically just going to iterate over our grid. Okay, so we're going to iterate over the entire grid array. We're going to blank out all of the values, and then we are going to basically scan the board and find any tiles that are on the board and actually assign the locations or the transforms of those tiles to the grid array. So here we go. We're going to start with basically, we're going to start with a for loop. So for int y equals 0, y is less than grid height and plus plus y. And for int x equals 0, x is less than grid width and plus plus x. And then we are going to basically check to see if the location that we're at, so grid x, y, doesn't equal null. Because if it equals null, then we don't care, and we are not going to do anything with it because it's already null. We also want to check to see if the grid is part of the transform. So we want to see if the parent is equal to the transform, right? So the transform being the transform of the game class, meaning the grid game object. Because remember, we're assigning the tiles when we generate them, we're assigning them to be children of the grid game object. So that in turn is this transform. This transform, right, we're checking to see if whatever's at this location is, if we're the parent of that, okay? And if that's true, then we're going to set the xy coordinate, or not the coordinate. See, this is where it gets confusing because we're not using, this isn't literally a coordinate. These are indexes in a multi-dimensional array. But we're using the same coordinate system that we have for our grid for our multi-dimensional array, so that we can, more easily, so that we can manipulate things a little easier. Okay. So when we're done with this, we've now just blanked out the entire array everywhere there was a null. Now we're just going to go in and we're going to do another loop, and it's going to be a for each loop. And we're going to pass in tile from our transform. I'm going to create a vector 2, call it v new vector 2, and we're going to round up the positioning of the tiles, so position.x, and we're going to use mathf to do that rounding. I'm going to do position.y. Right, and then we're going to finally, just in the grid, we're going to cast an integer. I'll explain why in just a second. And we're going to just do the same thing with the y. All right. So the way this works is we are creating a vector 2. Well, first of all, we're doing a for each loop. And in a for each loop, we're basically iterating over everything in the transform. So everything that is a child of our transform, we're going to iterate over, right? So for every tile in this transform, right, or for every transform in this transform, we're going to store that transform in the variable tile. We're then going to create a new vector 2 using the position of that tile, so x and y of that tile, and then we're going to take that, we're going to use these values as the indexes in the grid array, and we're going to assign that tile transform to that to those indexes in the array. The reason that we have to cast integers to these is because the vector 2 returns floating point variables as the properties for the coordinates. So x and y are actually floats, and the grid array uses indexes, has to be integers in order to specify where in the array you need to store or access information. So we have to cast those as integers, which is fine because we're rounded up, so we have whole integers to work with to begin with. But we do have to tell it that those are integers. Anyways, So basically, that's it. The update grid. We just need to call that from our generated new tile or generate new tile method. So after the for loop, we go in and we just call update grid. And what that does is it just calls this. It basically wipes out everything that's in the array. It's going to scan the board for new tiles and then add those back into the array. That'll make it super simple for us to keep track of all the tiles and see where they're going. And for future reference for when we actually start to manipulate and working with merging tiles and moving them from place to place. And it's going to get really complicated, believe me. We're getting there slowly but surely. We're making progress. Okay, this is how we do things. We start from scratch with nothing, and we're like, okay, well, this works only because I'm outputting something to the console and I can see that it's doing it, but I don't understand what it's for yet. I think once we get like a couple more tutorials in, you guys will start to see the bigger picture of how things are going to start tying together. But I think that this tutorial might have already done that in a way. I mean, at least we are now at the point where we've got some visual things happening. The next tutorial is what's going to be really fun. We're going to get into the movement. So we're actually going to start moving tiles around. So left, up, down, right. All these movements we're going to start working on and updating the grid for that. And so that'll be a fun one. But for this, I mean, this is it. This is the end of the tutorial. We're not going to cover anything else. I think it's already gone on too long. And I just want to say that I'm really, really excited to be back on YouTube after being on for such a long time. I didn't have the time, and I didn't want to half-ass the tutorials. I like taking my time to do them right, because I think you guys appreciate it, and I appreciate it. I appreciate you guys coming to check out my channel to watch these tutorials. I never actually thought that I was going to have this many subscribers. I mean, I'm literally like at the cusp of 2,000 subscribers. How awesome is that? Like, there's 2,000 people in the world watching me write tutorials. How cool is that? I love it. Anyway, so enough rambling on. If you like the channel, do me a favor, subscribe, hit the bell, share it with your friends, do whatever, and help me get more subscribers. That'd be great. If you like the video, give it a thumbs up, and I will see you guys next time.